Good morning, everybody, and welcome back to another amazing video lesson. Today we're going to be talking about air resistance and terminal velocity, but this will review a little bit from tomorrow. Of course, we're in the house that's divided. You know which side I belong to. Hope you guys are doing well. Let's do a little review from yesterday. Yesterday we talked about free fall. Remember, free fall of an object is when gravity is the only force acting on it. So in a vacuum, like on the moon, you saw the video of the hammer and the feather falling at the same rate to the surface of the moon. They did that. Proved Galileo was correct that bodies near the surface of two objects of different masses will fall at the same rate in a vacuum if you neglect air resistance. I also saw that done in a giant silo. They took all the air out of it. That was really a cool little video that showed a bowling ball and a feather, a group of feathers falling at the same rate in a vacuum. So that's technically in free fall. Skydivers are not in free fall. Hope you enjoyed the vomit comet video. That was kind of fun. You can actually take a ride on that. I think there's one down by Orlando. You can charter a flight on that and experience microgravity or weightlessness as you fall at the same rate with everything in the plane. If you go to the International Space Station, which you can if you have an extra $10–20 million laying around, the Russians will take you up there. The people and everything on the space station, International Space Station, are actually in free fall, but they're going around the planet. Gravity's pulling down on them, but they're going so fast horizontally or perpendicular to the pull of gravity towards the planet that they literally fall around the planet. We'll get more of that next week, that kind of stuff. But everything in the space station is falling, so you get that sense of dropping 24 hours a day on the space station. So if you can't take that kind of motion, you're not going to be able to be an astronaut. That's what they have to be able to live within. All right, so today we're talking about air resistance and something called terminal velocity. Let's get right into it. So here's your definitions, and pull those up here. Here we go. Air resistance is when objects traveling through air experience this type of fluid, it's a fluid friction, obviously air, also known as drag. The amount of air resistance depends on two things: surface area and velocity. I'll talk about those. And then we'll get into terminal velocity, which is the greatest velocity a falling object reaches. Okay, since we're talking about gravity, we're talking about falling objects, where the force of gravity equals the force of air resistance. So first of all, air resistance depends on surface area and velocity. And not only falling objects, but objects traveling through the air. You probably have this experience already. Excuse me, you're in the car, you're going down the road, the window's open, you put your hand out the window, and you can feel that air pulling back on your hand, okay? If your hand is nice and flat, you have a big surface area. If you put your hand like this, you don't feel that push from the air resistance as much because air's more streamlined. Your hand is more streamlined, it's more aerodynamic. So surface area is one thing it depends on. In the case of a falling object, if I have, a piece of paper and that one is balled up and one is flat, obviously this is going to have more surface area when it's falling, so it's going to float down, whereas the wadded up one will fall a lot faster. So surface area, oops, I dropped my feather. Also, velocity. Back to your car example, you put your hand out the window in the car and you're doing 30 miles an hour, you feel a little bit of a pull or push from the air resistance. Well, if you put it out there as you're accelerating, you're doing 50 miles an hour, you feel a lot more resistance. So air resistance increases with velocity. The faster you're going, the more force, more air resistance there is. Okay? In the case of falling objects, objects falling through the air reach a certain point where gravitational pull on that object equals the force of air resistance pushing up on it, and it will not accelerate anymore. Okay, so skydivers jump out of an airplane. They can only accelerate to a certain speed, depending on the body type, depends on body type and how much surface area you have, about 120, 130 miles an hour. Okay, is your terminal velocity. You're still doing 120 miles an hour down towards the earth. But air resistance pushing up on the person won't let that person go any faster. That's called terminal velocity. Okay, again, when the greatest velocity a falling object reaches, when the force of air resistance equals the force of gravity. So on this feather, you get an object like a light feather, not much mass, a lot of surface area as this thing falls. That's pretty much its terminal velocity. That's about as fast as that's going to fall. Okay, right there. Not much after I let go, it's already at its maximum speed. It's not accelerating anymore. Which one would have a higher terminal velocity? This light little ping pong ball or the bowling ball? Which one is going to achieve a greater speed before it stops accelerating at its terminal velocity? Right, the bowling ball. Terminal velocity of this bowling ball is about 300 miles per hour. So if I drop this out of a plane, it's going to keep accelerating and accelerating and accelerating until it hits about 300 miles an hour. Believe it or not, air resistance is not going to let this bowling ball go any faster. It's nice and heavy. It's nice and aerodynamic, so it will achieve a greater speed than a skydiver. Ping pong ball, not very fast, probably less than 20 miles an hour. Okay, I think I remember this one's about 15 miles an hour is the terminal velocity of a ping pong ball. All right. Here's a list of, I got to put it on the magic screen, some terminal velocities. Okay. Hope you can see that. Okay. There we go. So there's your terminal velocities. Again, the greatest speed a falling object achieves when air resistance matches gravity. Skydiver, about 60 meters per second. We don't know miles per hour. We know miles. About 134 miles per hour. A baseball, you drop a baseball off throw it out of a plane or off a high building, about 75 miles an hour, 74 miles an hour. A golf ball, about 72 miles per hour. A hailstone, about 30 miles an hour when a hailstone comes down. And a raindrop, about 20 miles an hour. Okay? Ping pong ball is about 15 miles per hour. Okay? Bowling ball, about 300 miles per hour. This feather, a couple of miles per hour. Okay? Not falling very fast. Okay, so what you're going to do today then is we go to your lessons. I got a cool video for you to see today too. Okay, you've got air resistance video to watch, terminal velocity video to watch, and then indoor skydiving is kind of cool. There's places around the country you can do this. Again, in Orlando, there's one of these indoor skydiving places, and what happens is they push air. I've seen giant fans underneath a screen or that air flows upwards. So air flowing upwards, and you stand over this and lay flat, and so the air pushes up on you like you're skydiving, except you're not falling. It's the air that's moving 120 miles per hour upwards on you. You're not falling out of the plane at 120 miles an hour to reach terminal velocity. The air is being pushed up through this chamber that you're in at 120 miles an hour, and you hover over it. It's pretty cool. And again, it's one of those things you can do when you're down in Orlando. And then the final thing is this physics simulation. Now this one happens quickly. So what you do, excuse me, here's your physics simulation skydiving. You have some questions that you need to answer. I would pull up the question sheet first and look at that, read over the questions, because this thing, you might have to run this a few times. The interactive, there it is right there, and it's already running. Okay, open it up. You can see you've got a velocimeter right here. There's a velocimeter telling me how fast it's going. There's your weight of the object, which is gravity pulling down on a little red cup, and then the air drag. And then you're going to click over here on this gold bar and see what happens. and watch the numbers before it hits the ground. The arrows, the vectors are increasing as velocity increases and drag increases. And there's some questions for you to answer. If it goes quick. So you may have to do it a couple times. Just go back into your lessons, click it again, open it up again, and get it started, and watch the numbers. You have to do it, 3-4 times to get the right numbers. Okay? Everything does happen quickly. This is without parachutes. You can mess around with the parachutes later, but you're not. For the questions, there's no parachutes involved. Just a falling object. So we're talking about terminal velocity and air resistance and how those are related today. So get that submitted. Fill it. There's a Google Doc for you to submit on that. And if you have outstanding work, some work that hasn't been submitted yet, please get that in as soon as possible so we can get that graded into the grade book for you on progress book. Check progress book for what's missing. Might be having some issues with some things being submitted, the brain pops, forces and gravity, and also the free body diagrams. Make sure you're using my correct email. Some are being sent in and I'm not receiving them. So make sure you're using my correct email to send those to. On the free body diagram, you have to type in my email address and send that in. Make sure you're spelling my name correctly, Neubert. So it's R. Neubert at revereschools.org. Make sure that maybe that's why I'm not getting it. Or if you have sent it, and just take a screenshot of it, pop it off to me so I can give you a grade. The forces quiz, the gravity quiz, and the free body diagram, the 12 stars that's still out there. So, hope you guys have a good day. Should be a nice day to get outside, sunny, and that's all I have today. A nice short little video, and I'll see you tomorrow. Go Buckeyes.